Welcome to HB Tuner's GM Gen 5 training part 36. In this training module, we're going to be taking a look at doing a breakpoint rescale for our MAF curve for higher power levels. So if you're putting a supercharger or a turbocharger kit on your naturally aspirated LT engine, we need to go in and perform the rescale. I'm going to show you the process of how to do that using an Excel spreadsheet calculator I'm providing in our training course. We're going to have a lot to cover. Let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at how to properly perform a mass airflow rescale for higher power levels. This is going to be something you're going to run into with an LT1 or an LAD6 engine. They're naturally aspirated from GM, and if we're putting a supercharger or turbocharger on them, we're going to max out the mass airflow calibration table really quick. We need to go and perform a rescale so we have more usable resolution or data points to figure out our airflow correlation at the frequency the mass airflow is going to be registering at, what that correlation is going to be. We don't want to have the upper end or the upper range of the MAF table having one or two data points. We need to stretch that out so we're able to hit more data points and more accurately determine what that air mass representation is going to be in our mass airflow calibration table. Let's jump in here. Let's take a look at where we're going to look at in the table and then start to unpack what I'm trying to show here so it's going to make a bit more sense. If you're a Z06 application or a ZL1 application where it's factory supercharged, you'll find that GM has already scaled out the tables for much higher power levels than even if you're putting a pulley on, basic bolt-ons in a cam, you're probably not going to be reaching. But if you're putting on a bigger blower or you're really getting aggressive and trying to make a lot more power, maybe you're putting even larger supercharger on, then you may need to perform a rescale. But what we'll show here for the naturally aspirated rescale will still work and be applicable to rescaling a Z06 MAF curve. So let's jump in here and take a look at a L86 here. I'm going to be looking at my Yukon Denali. It'll be the exact same process for an LT1 engine and adding on force induction. So I have my Yukon Denali file open here. This is my stock equivalent file. I have not rescaled or touched the mass airflow curve in this particular example yet. Let's take a look at doing the rescale option. Now I anticipate putting a Magnuson supercharger on my Yukon here very shortly when it comes in from the manufacturer. I've been waiting for it for a bit of time right now with all the back order delay in parts. Once I get that, this file here will be prepped in anticipation for the supercharger, and once it arrives I can simply bolt it on and start calibrating. I don't have to go back in and perform this rescaling later point in time. So let's jump in here and take a look at how we're going to be doing this. I'm going to jump into my engine tab right here, and we're going to move from engine and going from general over to airflow, and then in airflow here, let's jump right into our airflow versus frequency curve. Now at this point, we've covered dealing with the mass airflow pretty extensively. You should know what the MAF curve represents. I don't need to go over all the details and the fundamentals of what's going on here. Let's jump into the last bit of the table so we can start unpacking what we have going on here in this MAF table. We can find here the breakpoints are moving in roughly 150 hertz jumps in each breakpoint movement. So under the frequency, we have the airflow that we're going to be correlating to that frequency. We know how to rescale and recalibrate this table so that relationship is tracking accurately and we're accurately representing our air mass. So the dynamic airflow or dynamic air mass channel is going to be accurately representing our airflow coming into our engine when we're in our high-speed MAF only mode. Now in this situation here, what we're going to be noticing is that the last frequency breakpoint, that's 9600 here, and then it jumps, or the second to last I should say, and then it jumps to 15,000 hertz. The upper limitation of the factory mass airflow sensor is in fact 15,000 hertz. So this is going to be the highest that the output frequency can go to. Now we're finding here the jump between 9600 hertz to 15,000, it jumps from 341 grams per second to 922.18 grams per second. That's a lot of airflow that it could potentially register at 15,000 hertz. Now GM has chose to scale the table like this because in this naturally aspirated form, we're performing on the upper last bit of the table here. This is usually going to be where we find our peak breakpoints or the peak output frequency from our mass airflow sensor itself. We can actually take a look and just confirm this. Let's take a look at a data log here from this exact vehicle. So let's jump into our VCM scanner. We take a look. I have a wide open throttle pull open. I don't know if this was a open loop MAF tuning log or if it's speed density, doesn't really matter. I have the mass airflow hooked up the entire time. What we need to note here is taking a look at the engine speed, and we want to take a look at what this frequency is going to be as well.
The frequency, we're looking for the highest value here so we can get a determination of where we're at in the table. So as I move up here, we can see as I'm going up in my engine RPM, that frequency is starting to increase and the highest value.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.